हेलो स्टूडेंट्स, इस वीडियो में मैं आपको कुछ डिफरेंट टाइप की प्रॉब्लम्स ऑन द बेस्ड ऑफ डिफरेंशियल कैलकुलस करना सिखाऊंगा। तो देखो, इस प्रॉब्लम में गिवन मैं x is equals to a in bracket theta plus sin theta and y is equals to a in bracket 1 minus cos theta, then prove that dy divided by dx is equals to tan theta by 2. So this is tricky question. इसमें देखो क्या गिवन है। इसमें दिया है कि x will be the function of theta and y will be also the function of theta. So we can differentiate x with respect to theta as well as y with respect to theta. So to find dy divided by dx, we will write dy divided by dx equals to dy divided by d theta then whole divided by dx divided by d theta. So let this as equation 1. Simply to find dy divided by dx, we will calculate dy divided by d theta, then dx divided by d theta, then we will substitute these values in this equation, so we get dy divided by dx. So now to calculate dy divided by d theta, we have to differentiate y with respect to theta. So just substitute the value of y, so d divided by d theta, in place of y there is a in bracket 1 minus cos theta. तो डिफरेंशिएट करने के लिए देखो क्या करेंगे, d डिवाइडेड बाय क्या इन ब्रैकेट इस अंदर मल्टीप्लाई कर देते हैं a माइनस a cos थीटा. अब डिफरेंशिएट करोगे तो a कांस्टेंट है, उसका 0 आएगा और a cos थीटा का माइनस a एज इट इज रहेगा, cos थीटा का आएगा sin थीटा माइनस sin थीटा, minus minus will be plus, so overall that will be a sin theta. The value of dy divided by d theta will be equal to a sin theta. And this is equation 2. Now similarly find dx divided by d theta. So d divided by d theta, substitute the value of x. Here x is equals to a in bracket theta plus sin theta. So a in bracket theta plus sin theta, इसे अंदर मल्टीप्लाई कर ले, इट विल बी d डिवाइडेड बाय d थीटा a थीटा प्लस a sin theta. Now differentiate it. So as we differentiate a theta with respect to theta, there will be only a, and the derivative of a sin theta with respect to theta will be a cos theta. It can be considered as a common, so there will be a in bracket 1 minus, there will be a in bracket 1 plus cos theta. And this is equation 3. Now substitute these values from equation 2 and 3 in equation 1 to get y divided by dx. So from equation 1, 2 and 3, dy divided by dx is equals to a sin theta divided by a in bracket 1 plus cos theta. Now simplify it. It will cancel out, so there is only sin theta divided by 1 plus cos theta. To simplify, we will use trigonometry. In place of sin theta, we can write 2 sin theta by 2 cos theta by 2 divided by 1 plus, in place of cos theta, we can write cos square theta by 2 minus sin square theta by 2. Now further simplify, because in place of 1 minus sin square theta, 1 minus sin square theta by 2, we can substitute cos square theta by 2. It will be 2 sine theta by 2 cos theta by 2 divided by 2 cos square theta by 2. Now 2 will cancel out this one, and the power there will be only sine theta by 2 divided by cos theta by 2. As we solve it, it will be tan theta by 2. हैंस प्रूव, इसी को तो प्रूव करना, इसमें आपने देखो डिफरेंशिएशन के कॉन्सेप्ट तो यूज किए, साथ में ट्रिग्नोमेट्री भी यूज हुई. Now second problem, it is also very similar as we discussed first one. So here we find dy divided by dx can be written as dy divided by dt whole divided by dx divided by. This is equation 1. Now find dy divided by dt plus d divided by dt. In place of y we can substitute b t square. Now differentiate it. It will be 2. Now the value of dx divided by dt, that is d divided by dt, substitute the value of x, d dq. As we differentiate we get 3a t square. Let this is equation 3. Now substitute these values from equation 2 and 3 and equation 1. So we get y divided by dx equals to dt divided by 3 dt square. Now simplify it. So 20 will cancel out. B divided by 3 at. That will be the derivative. Now third problem is also very similar. So to find dy divided by dx, we'll write y divided by d theta whole divided by dx divided by d. That this is equation 1. So value of dy divided by d theta, that is d divided by d theta. In place of y we will substitute b sin theta, b sin theta. Now its derivative, b will be the constant, then as it is. Now the derivative of sin theta, the cos theta, that this is equation. Now the value of x divided by d theta, that is d divided by theta a cos theta, because the value of x a cos theta. We differentiate, we get minus a sin theta, that this is equation 3. Now substitute these values, equation 1. So we get y divided by dx equals to b divided by minus a sin theta, this minus b divided a cot theta. That will be the answer. Now in next problem we will discuss the use of the differential calculus in physics. So आगे कुछ प्रॉब्लम्स है जिनमें हम आपको बताएंगे कि डिफरेंशियल कैलकुलस का यूज फिजिक्स में कैसे करते हैं और क्यों इसकी जरूरत पड़ती है. So in this problem, if the displacement x of the particle is related with time according to the given relation, where x is equals to 2t cube minus 3t square plus 2t plus 2. इधर आपको निकालना है पोजीशन, वेलोसिटी एंड एक्सीलरेशन ऑफ द पार्टिकल एट द एंड ऑफ 2 सेकेंड. तो ये बताना है. तो इस टाइप की प्रॉब्लम में हम डिफरेंशियल कैलकुलस का यूज करेंगे. सो हियर पोजीशन given that x is equals to t cube minus 3t square plus 2t plus 2. Now we find position after 2 seconds. So just substitute t is equals to 2 in this equation, equation number 1, to find position after 2 seconds. Now position after 2 seconds written as x t is equals to 2. This is the way to write. So we just substitute 2 in place of t. So there will be 2 in bracket 2 raised to power 3 minus 3 in bracket 2 raised to power 2 plus 2 in bracket 2 plus 2. Now simplify it. That is multiplied by 8 minus 3 multiplied by 4 plus 4 plus, now further simplify, 16 minus 12 plus 4 plus 2. As you solve it, you will get 10 meter. So that will be the position of the particle after 2 seconds. So this is the way. Now velocity. So what is the way to find velocity? So the first order derivative of displacement will represent velocity. To get velocity, we just differentiate x with respect to t. It is 6t square minus 6t plus 2 only. So this is the velocity. This is called instantaneous velocity. Now its value at t is equals to 2 seconds. So now velocity at t is equals to 2 seconds. Substitute 2 in place of t. This will be 6 into 2 raised to power 2 minus 6 into 2 plus 2. Now simplify it. That is 6 multiplied by 4 minus 12 plus 2. Now further simplify. So as we will simplify, it will be 14 meter per second. So that will be the velocity of the particle after 2 seconds. Now acceleration. So we further differentiate velocity with respect to the time, then we get acceleration. Acceleration means dv divided by dt. Further differentiate this one. As we differentiate, we get 12 t minus 6. Now velocity, now acceleration after 2 seconds. So we substitute 2 in place of t. So acceleration after 2 seconds, that is 12 multiplied by 2 minus 6. Now solve it. 24 minus 6, that is 18 meter per second square. This is the use of the differential calculus in physics. This problem will also explain the use of the differential calculus in physics. In this problem, angular displacement is given. Theta is equals to square divided by 20 plus t divided by 5. We have to calculate angular velocity, means the rate of change of angular displacement is called angular velocity. Here angular velocity written by omega. Omega is equals to d theta divided by dt. We differentiate theta with respect to t. That is 2 divided by 20 into t plus by 5. This is the derivative. This expression will represent angular velocity of the particle. Now angular velocity at the end of 4 seconds. So we substitute 4 in place of t. Angular velocity at t 4 is 2 divided by 20 multiplied by, substitute 4 in place of t plus 1 by 5. Now simplify it. It is by 5 plus 1 by 5. Further simplify, so 3 by 5. All we get 0.6 radian per second. Radian per second will be the SI unit for the angular velocity. So this is the answer. Next problem में rate of increase of area निकालना है. Means we will calculate A divided by dt. Differentiate A. Value of A given. The value of A. Differentiated. Get D divided by dt. Base of A 5t square plus 40 plus 8. Differentiate, we get t plus 4 only. Now at 3 seconds. dA divided by dt. If t is equals to 3 seconds. Substitute in place of t 3 and multiplied by 3 plus 4. That is 34 meter square per second. This is the solution. Now next problem. In this problem, displacement x is equals to 2 plus 5t plus 7t square is given. To calculate initial velocity, we differentiate. First we calculate its instantaneous velocity. Instantaneous velocity v is equals to dx divided by dt. Differentiate, that is 5 plus 14t only. Clear? Now instantaneous velocity means velocity at t is equals to 0. Substitute 0 in place of t. This is 5 plus 14 multiplied by 0. That will be only 5 meter per second. Now velocity at t is equals to 4 seconds. Yes, t is equal to 4. Substitute 4 in place of t. As we substitute, we get 5 plus 14 multiplied by 4. Yes, 61 meter per second. Now uniform acceleration. Further differentiate, acceleration is equals to d divided by dt. Further differentiate, is only 40 per second. It is uniform because it is independent from the time. Now displacement at 5 seconds. So you get displacement at 5 seconds. We substitute 5 in place of t in this equation. So displacement at t is equals to 5 seconds. 2 plus 5 bracket 5 t is by 5 substitute plus 7 5. Now solve it. Plus 5 plus 7 multiplied by 25. It is 27 plus 175. We get 202 meter. This is the answer. Now next question. Here the displacement of the particle is given. Y is equals to r sin theta in bracket omega t minus theta. We want to calculate its velocity and acceleration. So here given is y is equals to r sin omega t minus. Now to find velocity, we differentiate y with respect to t. Now differentiate. We differentiate, we get omega r cos omega t minus theta. So this is the velocity of the particle. Now to get acceleration, differentiate velocity with respect to time. As we differentiate, we get minus omega square r and omega t minus theta. In place of sine omega t minus theta, we can substitute y, so it is minus omega square y. This is the velocity, this is the acceleration. Now in this question, find the slope of a tangent drawn at a point 1, 0 of the given curve. Y is equals to x square plus 1. As we know that slope means the derivative by the geometrical meaning of differentiation. Slope is y divided by dx. Now differentiate y, so it will be only 2x. Now the point, so at point 1, 2, slope at point 1, 2, we will substitute 1 in place of x. We get 2 multiplied by 1, 2. That will be the slope. It's so simple. Now next problem. The area of the circle of radius r is pi r square. सभी को पता है area of circle given by pi r square. We have to prove the rate of increase of area with respect to radius is equal to circumference of the circle. So here area A is equals to pi r square. Now the rate of change of area with respect to radius, it is dA divided by dr. Differentiate, we get 2 pi r. What is this? This is the circumference. Now next problem. The radius of the circle is increasing at the rate of 3 centimeter per second. Find the rate of increase in its area when the radius is 10 centimeter. Area of circle is given by r square. Now the rate of increase of area with respect to time, so it is dA divided by dt. It will be 2 pi r dr divided by dt. In the given question, dr divided by dt is given. One value of dr divided by dt and r is also given 10 centimeter. Now substitute these values. Just 2 pi multiplied by 10 multiplied by 3. Thus 60 by meter square per second. Answer. Students, these are the problems based on the differential calculus. I hope all of you are able to understand the use of the differential calculus and able to apply the concept of the differential calculus in physics. In next video, we will discuss about the integral calculus.
Please like and subscribe Physics 21 and keep watching. To download note in PDF format, link given in description. See you again.